As I mentioned at the end of the previous video, in this video we are going to talk about some small concepts, in which the first one is this static keyword. You can assign a static keyword for different methods and also different variables. Let me create another class in here. Let's just call it static test. In here I can create a variable as we did 1,000 times. For example, let's say int number is equal to 0. I can have a static keyword in here after the access modifier and before the data type. I can say private static number. And if you noticed, as soon as I changed the type of this variable to static, the name of my variable somehow changed to italic. When you define a variable or a method as static, that variable or method belongs to the object itself. I mean this class in this case, but not to the instances of that class. What I mean by that, let me show you in a minute. For example, let's have some other fields for this class, maybe a name and maybe an ID. If I want to create a constructor, you can see that I don't see that static variable inside this dialog. I can create my constructor, and later on if I try to define and instantiate an object of this class, for example, if I want to say static test is equal to new static test like we did 1,000 times, we need a name in here and maybe an ID. This is an instance of our class, our object in Java. If I want to have access to that static variable, let's just before that change this one to public, because we want to have access it from other classes. Right now, if I want to have access to that number, to that static variable, I can say static test dot number. Let's initialize it, or let's change its value to 5. The value of that variable would be changed, but as you can see in the warning, the static member has been referenced via the instance of our object. It means that I can change the value without instantiating the object. For example, I can say static test with a capital S dot number. You can see that I don't need instantiation for my object. I can say 7 this time. It's important to know that if you change the value of a static variable in one place, it will be changed in all of your application, in all of the instances of that object. For example, let's delete this line and let's create another instance of my object. Let's call it second static test is equal to new static test, Sarah and an ID. You can see that I'm never changing the value of that number, but if I try to print the value of this static variable for my second class dot number, we should get 5. Let's try running our application. It's the first time, so I'm getting the warning. Let's run it once again. You can see that 5 has been printed. Once again, as I said at the beginning of this video, the static variables and methods belong to the object itself and not to the instances of that object. Let's also create a static method in here. Let's just say public static void print name. Let's receive a name, string name, and simply print that name. Now, if I want to have access to this static method without instantiating, I can simply say static test, the name of my class with a capital S, dot print name. Let's say Mason in this case. Let's run our application. Once again, you can see Mason has been printed. I can even delete all of this instantiation just to see that we can have the same result without creating any instance of our class. Also, it's important to know that when you define a method as static, you can only call static variables and methods from inside that method. For example, if I try to have access to this name from up here, because it's not a static variable, I can't have access to that. Let's try printing the ID, for example, because we have a name here. If we take a look at the error, we can see that non-static field cannot be referenced from a static context. Similar for our non-static methods. For example, if I create another method in here, let's just call it print. This time, if I try to print the name, and later on, if I want to call this method from inside this static method, let's just say print, you can see I'm getting an error, and the error says that non-static method cannot be referenced from a static context. So be aware that you can only call static methods and static variables from inside a static method. But why would we want to use the static keyword in different variables and different methods? Well, one of the reasons is that you want your variables, for example, to be the same at all instances of your object. Imagine you have created a class in order to simulate the employees of a company. For example, you want to save their names, maybe their payment, or everything else. You know that in all instances of that class, the name of the company should be the same. So you can define a static variable and it will be the same at all instances of that employee class. Also, some might say that static variables are more memory friendly because you define your variables once in the object itself, and from that point it will be the same in all instances of that object. So it will only occupy, for example, as many memory space as one integer could occupy in your memory RAM. And the reason you might want to declare your methods as static is that sometimes you don't want to instantiate or define an instance of your object. You just want to call some methods, for example, from inside another class. In those cases, you can use a static keyword. Okay, I think that's enough for static keyword. Just to have a review, the static methods and variables belong to the object itself and not to the instances of that object. I just don't need this class anymore, so I'm deleting it. The other topic that I'm going to talk about is inner classes, or maybe some call it nested classes. Let's talk about that in another class. Let's call it test nested classes. Inside your classes, inside the curly braces of your classes, you can define another class. Let me define one. For example, I can say private class. Let's call it inner class. You can call it whatever you want. And another pair of curly braces. We have defined an inner class or a nested class inside a parent class. There are some advantages of using nested classes. For example, if I have a private member variable up in here, for example, let's say private int number, even though the access modifier of this number is private, I can have access to that number from this nested class. For example, I can say number is equal to some number. But for that, I need to create a method first in here, because we are inside a class. Let's create a method, private void, let's say print number. Inside this method, I can print my number. You can see that even though the access modifier of this member variable is private, I have access to that number from inside this inner class. Also, when you use inner classes inside another class, your code would be much more readable and maybe easier for eyes to follow the logic that you have been writing in your code. In this course, we are not going to use that much of inner classes. In fact, the first time that we are going to use inner classes is in the 8th session, I guess, when we define an async task. But more on that in future videos. Okay, let's delete this class as well. The other concept that I'm going to talk about is interfaces in Java. We can create an interface like we created a class in Java, for example, from this new Java class dialog. Let's call it test interface. But this time, instead of a class as the kind, I can click on this drop down and select interface. By pressing OK, I have an interface. You can check the icon from here. It's different from the class icon. You can think of interfaces as a contract between different parts of your application. For example, between two different classes in your application. You can define an abstract method inside an interface which only indicates the return type and also the input type of your interface. For example, let's define an abstract method in here. I can say public, for example, void. Let's call it print. A pair of parentheses. Let's just receive a name. That's it. When we define a method inside an interface, we can't have a body. I can simply put a semicolon in here, and if I try to put a pair of curly braces, I can see a warning that interface abstract methods cannot have body. So I can't declare my methods as I did in a Java class, for example. By this way of defining a method inside an interface, we are doing something called abstraction in Java. Basically, abstraction means that you are hiding the process of doing something from the user. For example, in here we are only showing the functionality. The functionality of this method is to print something as the name applies. The return type of this method is void, it's not returning anything. And also the input type of this method is a string called name. Later on, in different part of my application, I can implement this whole interface, and maybe from another part, I can call this method. So we would have a contract between two parts of our application. Also, as long as I'm here, I would like to talk about this public in here. It's somehow gray, as you can see, and that's because access modifier doesn't mean anything inside an interface. It means that all the methods and variables inside an interface are by default public. You can't put something like private in here. You can see that I'm getting an error. Modifier private, not allowed here. So you can't have private or maybe protected variables and methods inside an interface. Interfaces are just like a contract. Okay, but how do we implement this interface? For example, let's create a Java class in here. Let's call it test class. This time the kind should be class. At the declaration of my class, after the name of that class, I can type implements. This class implements our interface. For example, test interface in this case. But I'm getting a warning, and that's because I need to implement all the methods inside that interface. The way that I can do that is by clicking on this red line in here and using this red light bulb and implement the necessary methods. For example, you can see the print method that I created inside my interface. By pressing OK, it's implementing that method. The other way is to simply come inside the curly braces of your class and press Ctrl I. This way you have the same dialog. Or there is another way by going to this red line by pressing Alt Enter. You can see the first one is to implement a method. We have the dialog and we can implement the print method. Now that I have implemented this method, I can use the name that has been passed to this method. For example, I can print that name. But where do we call this method? We can call it from our main class, for example. In here, first of all, I need to create an instance of this interface. I can say test interface. Let's give it a name. Test interface is equal to new. In here, I can type in test interface, but it's generating all of those methods inside the interface. In some cases, you don't want this. Instead, you can type the name of your class, and we will talk why this is going to work. Why this test interface is equal to our test class. Because we are implementing that interface in here, the Java compiler knows this class as this interface. And that's the reason we are not getting any errors in here. Now, if I want to use that print method, I can say testinterface.print. We need to pass a name here. If I try to run my application, I should see Mesam in the console. It has been printed. I think I have used the term compiler a few times in this course up until now. Basically, compiler is a piece of application that will change your code to zeros and ones to be readable by the machine, by your computer, or maybe your user's device. That's all the compiler does. In fact, we don't need to be worried about what compiler does at all. Okay, let's have a quick review of what we have done in here. First of all, we have created this interface, which once again is a contract between two parts of your application. We have implemented this interface inside the declaration of our class, and later on, for example, from our main class, we have called that method. And if you want to make sure that this code is running from inside this class before this printing name, you can print this, which I said that this refers to the current object that you are in. In this case, we are inside test class. It should print the name of our class. If I run my application, you can see that it has printed the name of our class inside our package. This way, we are sure that this method has been executed from inside this class. It's also worth noticing that you can implement multiple interfaces inside your class, inside the declaration of your class. For example, if I have another interface in here, let's quickly create one. I can create a method in here just to show the addition of two numbers. For example, I can say addition, and inside the parentheses, I need to receive two integers. Let's say first number and second number. Now that I have created this interface, I can implement both of these interfaces inside the declaration of this class, but I need to separate them by using a comma. I can say second test interface, and inside the curly braces of that class, I can press Ctrl I and select that method. You can see that this time we have a return type which is integer, as I defined inside the interface. You can implement as many interfaces as you want inside the declaration of your class. Okay, let's summarize the usage of interfaces in Java. First of all, we use interfaces as a contract between different parts of our application. For example, in here we have a relationship between this test class and this main class. Later on in future videos, we will see that we can use interfaces to create a connection between two threads in Java. We will be talking about concurrency and threads in Java in the next video, but for now we just need to know that threads are some unit of execution in your processor, and the relationship between those different threads can be handled by, let's say, interfaces. Also, you might want to use interfaces to have some level of abstraction for your code. For example, if you want to create, let's say, an external library. We will talk about external libraries once again in future videos. But for example, if you are an extremely expert developer and if you want to create an external library, you might want to use interfaces. You don't want the rest of the world what you are doing behind the scenes. You only need to show them this contract. For example, the return type of your method, the name of that method, and also the input type of that method. You may want to hide the process of doing something and just show them the functionality of your methods. Okay, I think that's enough about interfaces. The last thing that I'm going to talk about in this video is abstract classes. Once again, let's delete all three of these objects because we don't need them anymore. The usage of abstract classes is exactly as interfaces, but there are slight differences which I will talk about now. For now, let's just create an abstract class. You can create your abstract class similar to creating a new Java class. Let's call it test abstract class. But before the class keyword, you need to type abstract. By typing this abstract, you can see the icon has changed in here. As I mentioned, the usage of abstract classes are like interfaces. It means that we can have abstract methods inside our abstract class. For example, I can say abstract void print, and I need to finish my method like this. We can't have a body for our method. When we created an interface, we needed to implement that interface from the declaration of other classes. But when you create an abstract class, you need to extend from this abstract class. Let's create another class in here. For example, this test class in here, after the name, I can say extend the test abstract class. I need to override those methods. I can do so by pressing Alt-Enter and implement the methods. You can see that the print method has been overridden in here. Or maybe let's receive an input as this print. Let's say string name, and maybe later on in test class, string name, and print that name. Now that we have implemented this method, I can call it from my main class. For example, in here I can say test abstract class, let's call it test abstract class, is equal to new test class this time, like we did for interfaces. Then after the defining and instantiating, I can say test abstract class dot print, use that print method. Let's pass my name once again in here. You can see that my name has been printed. You can see that the usage of abstract class is exactly like interfaces. For example, we use that for abstraction and also for connecting different parts of our applications. But there are few differences. For example, you can only extend one abstract class in the declaration of your class. You can't have, let's say, multiple abstract classes. That's not how it's works. In another word, abstract classes doesn't support multiple inheritance. The other difference between an abstract class and an interface is that inside abstract class, you can have non-abstract methods. For example, I can say public void, let's say print name. As you can see, I can have non-abstract methods inside an abstract class. Also, I can have, let's say, fields in here, non-abstract fields. For example, let's say private int number. I can have them inside an abstract class. Similarly, we can have, let's say, constructors for our abstract class. These options we didn't have in interfaces. There are few more slight differences between an abstract class and an interface. You can check this web page at Oracle documentation. You can see the link up in here. They are explaining it down in here when you should abstract class and when you should interfaces. For example, they say that when your classes are related to each other, you should use abstract classes. When you want to have access modifiers beside this public, for example, private and protected, you should use abstract class. You didn't have this option inside an interface. Also, the third scenario in which you may want to use abstract classes is that you want to use non-static or non-final fields. We will talk about this final keyword in future videos, I believe, when we create a recycler view adapter, but it's worth noticing that all the methods and variables inside an interface are static, so if you want to use non-static variables, you need to use abstract classes. But in some cases, you may want to use interfaces. For example, when the classes that are going to implement the interfaces are not that related to each other, as they said in the first case. Or in cases you might want to use multiple inheritance. As we saw that we can implement multiple interfaces from inside the declaration of a class. I suggest you take a look at this page. It's useful, but if not, I think I have covered everything that you need in order to select between an abstract class and maybe an interface. This video was a little bit technical and maybe somehow boring, but we needed to know about these concepts in Java. We will be using interfaces a lot in this course, but not that much of abstract classes, maybe inner classes, and not even the static keyword. Okay, I'm going to finish this video in here. In the next video, we are going to talk about concurrency and threads in Java. See you in the next video.